This is a video on creating an equation for a quadratic function given some information. So we want to make an equation for a quadratic function. So remember, quadratic functions look like this. Well, they could look like this. Here's one in standard form. The key is they all have this x squared as their highest exponent. So that'll be in there somewhere. But we also have like vertex form and factored form. So let's see what kind of information we're given and then how we can make up the equation for this quadratic function. So let's say someone told us there's a quadratic function and we know this function has roots at -3 and 5. Say we know that. And maybe we also know it will pass through a point at 4 and -3. So let's say that's the information we know. So we know it has these two x-intercepts and we know it goes through a point. Let's just draw a rough sketch so we can see what it looks like. Okay, so we know it goes through the point -3, which is roughly there, and 5, somewhere over here. We know it goes through the point 4 and -3, so somewhere down here. So I think the parabola is going to look something like this. So now your goal is to just go whatever avenue you want to try to figure out the equation. So since you know your roots are at -3 and 5, you would actually be able to figure out where the axis of symmetry is. Because the axis of symmetry is going to be right in between those. So it's going to be right at 1. So you actually know just from this information that that the vertex is going to be at 1 something. So you know that information. So yeah, there's a bunch of different ways you can do this. I'm going to try it one way and then you can see if you can think about other ways. So you know what? You know how there's like a factored form for a quadratic? X minus r, x minus s. Like this is kind of like what a factored form equation would look like. Well, since I know what my two roots are, I'm actually going to use factored form to help me find the equation of this parabola. So I'm going to enter them in opposite ways. So I'm going to say like x plus 3 and x minus 5. Because then I know if I were to actually solve this, if I were to actually like set these equal to 0, I would have a root at -3 and I would have a root at +5. That's what I want. So I know my equation is going to look something like that, but I don't know if there's going to be an a value. So that's what I need to find out. So next I'm going to use this point information. So like I know it goes through the point 4, -3. So that's an x and a y coordinate. So I'm just actually going to sub those in for x and y. So y would be -3 and x would be 4. So I'm going to sub that stuff in and then I'm going to try to solve for a. So 4 plus 3 is 7. 4 minus 5 is -1. 7 times -1 is just -7. So I have -7a. I'm going to isolate a. So I'm going to divide both sides by -7. And I'll see that a is equal to 3/7. So if I sub that back into my equation here, I get y equals 3/7, x plus 3, and x minus 5. So that's the equation of my quadratic function. And I could put this in standard form if I want to. So I'll just expand out my brackets. So x squared minus 5x plus 3x will give me minus 2x, minus 15. And then if I multiply the 3/7 through, I get 3/7 x squared minus 2 times 3 over 7 would be 6 over 7x. And then 15 times 3 over 7 would be negative 45 over 7. So that would be my equation in standard form. So that's how you, like, if you're given the roots of a parabola and a point, it might be easiest to just pop that equation into into factored form, because it's easy to pop the roots in. And then just sub in this point for x and y so that you're able to find your a value. And then if you want to put it in standard form, you would just expand it. I was thinking it might not be bad to go through vertex form, but I don't know, give it a try and see if, would you be able to find this y value of the vertex? Is there another way that you could figure out the equation of this parabola? Maybe. So that's how you could create an equation of a quadratic function if you're given the roots and it passed through a point. So you have to be ready for any information. Like, they could give you information like this parabola has a vertex of 3 and 9, and it passes through the point at negative 1, 8. Ooh, negative 1. Yeah, 8, whatever. Just making this up, so we'll see what happens. So now they've given me the vertex. So now I feel like it might be easiest to start with vertex form. So just depending on the information given, it might be easiest to like pick a certain type of equation to start with. So in here, I could sub in 3 for my h value, 9 for k, and I'm left with not knowing what a is again. So to figure out a, I can sub this in for x and y. So 8 equals a, negative 1 minus 3 squared plus 9. And now I just isolate a. So negative 4 squared plus 9. Let me just quickly simplify this. So negative 4 squared would be 16a plus 9. I'll pop my 9 to the other side. So it would be 8 minus 9. So negative 1. Divide both sides by 16. I picked some pretty interesting a values. So a would be negative 1 over 16. So then I can just pop that back into my equation. So y equals negative 1 over 16, x minus 3 squared plus 9. And if I wanted to convert that to standard form, I would just go through all that stuff again, like expand the brackets, multiply everything by a. I'm not going to continue, but this is what it will, just keep going through expanding. So yeah, just depending on the information given, that's how you would create an equation for a quadratic function.